Now let's move on to the second part of it, which is more interesting, guys. And the things will go little tricky here. What is the drawback? If worker node goes down, you are in a mess. Okay? You don't have any way to recover your data. And for that reason, the Kubernetes says, hey, you know what? Instead of using empty directory, host path, I request you to create two different type. I request you to create persistent volume. Now let's start from here. Okay. You go ahead and create a persistent volume. And once the persistent volume is created, this is a cluster level component. So you are going to provision a storage, and this will be the cluster level component. Okay. So it means it is not created within a namespace. You have a chunk of storage and you just provisioned it. How you provisioned it? With the help of persistent volume. Now, what are the different type of persistent volumes you can create? We will discuss. Just give it a time. But for now, once the PV is created, in order to use this persistent volume within a namespace, so let's suppose that this is some kind of namespace. In order to use this particular persistent volume in your namespace, what you have to do? You have to use something called as PVC. You attach your persistent volume to persistent volume claim, and this kind of mapping is called binding. We also call it bind. Bind, it's one of the same thing. Now, you bind this particular persistent volume, which is a cluster level object, to the persistent volume claim, which is a namespaced object. And then you use this persistent volume claim within your pod. Okay. Now I'm going to make it a little more complex. Persistent volume. I said that I can create persistent volume out of many provisioners. There are many provisioners that I can use. Provisioners means the storages, right? I can create this persistent volume out of many storages. What are the type of storages that I can use? Now, for the sake of simplicity, I'm saying that I can use hostPath itself. Although I was using hostPath directly, but I can create a persistent volume which will use some kind of host path, which I would say is a kind of storage, which is mounted on that particular node. It is possible. Got it? Now, similarly, I can use NFS. Similarly, I can use AWS EBS. These are some of the provisioners that I can use. Okay. Now, how am I going to do it? It's up to me. I have to do it manually. If I want to use NFS on a particular cluster, I have to make sure that NFS is available. We will see this NFS example in a while. Okay, but definitely we can use elastic block storage as well to to be used by persistent volume. Now, what happens here, guys? Do you see the complexity? So basically, what is going to happen? In most of the organizations, we have the two different teams. We have the administrators, right? And we have the developers. Or for that matter, yeah, let's call them developers. So the responsibility of admins is to make sure that we somehow can use the host path and create a persistent volume out of it if we are creating or adding the additional storage and keeping the backup of that, right? Similarly, if we are using NFS, we have to make sure that we are creating some kind of NFS provisioner and then creating the persistent volume and then creating the persistent volume claim. Because who is going to know? Developer will never get to know that, what is the persistent volume that is getting created. Similarly, if we are using the EBS, maybe in most of the scenarios, you will see we are using all these three type of uh, storages within our cluster, because each of the project is different. We could have thousands of storages. So if we have such scenarios where admins keep on adding the persistent volume, the developers, if they have to provision it, request the admins to get the PVC created for the PVs. This is going to be a process in itself. And this is very cumbersome. This process manually is very cumbersome, very hectic. You might have to make sure that you are using some kind of incident management ticketing tool. If they are not using the PVC, then claiming it back, things like that. That there are many, management that we have to do. Now we will discuss, because I have not discussed the, claiming it back, right? It's like taking back the PVC from the pod. We have not discussed that point yet, but this can happen. So what is the solution? The solution is another type of object, which is called storage classes. Now, what is storage class, guys? Storage class is a kind of object that allows us to dynamically create the persistent volume as soon as somebody is requesting the PVC. I mean, some PVC is requesting the PV. Okay? It's like if there is any request from any particular pod that, hey, you know what, I am going to need PVC, it will further request some kind of PV, which will be dynamically created by the storage class object of Kubernetes. But from where it is going to create? Of course, the process will remain the same. Instead of creating persistent volumes directly, we will be creating the provisioners. So we will have NFS provisioners. We will have, so now the storages could be different, right? AWS, EBS provisioners. We could have many type of provisioners that we can install within the Kubernetes, and which can further create the persistent volumes dynamically as soon as the PVC is requested. And they also give us the functionality to ensure that if PVC gets deleted for some reason, the data still persists. Or other way around, we have, let's suppose that, when we are deleting the PVC, we want to make sure that the data does not persist. Do we want to do that? If yes, then the data will be deleted from here as well. So depending on the condition, what kind of PVC is requested, data will be managed accordingly. Now, I am going to repeat everything what I said, and now it will start making more sense to you because this is a Kubernetes documentation. Okay, now look here. A PV is a piece of storage in the cluster that has been provisioned by administrator or dynamically provisioned using storage classes. Good enough? Good enough. Now, it is a resource in a cluster just like the name, just like a node in the cluster resource. I request you that you read this section very, very carefully. Each and every line must be understood by you. Now, I will skip many sections, okay? This API object captures the details of the implementation of storage. Of course, it's a persistent volume. It's a real storage. It could be NFS, iSCSI, or some kind of cloud provider specific storage systems. EBS, S3, and file NFS, network file system, XFS, or anything. There are many that even I can't think of. Similarly, PVC is just a request for the storage by the user. It's nothing, but it's just a request. Pod till here, we were creating a volume, but we were not requesting anything. Till here, we were not requesting anything. There were no PVC. It was the direct mount volume which was getting mounted. That's it. But now we have PVC in between in the picture, which is nothing but a kind of, a request, a formal request for the storage, so that whatever storage we have within the cluster, that particular storage can be given to the respective pod. Once freed, it's the responsibility of PVC to hand it over again to the PV. That's it. There is a claim can be requested on specific size and access modes. So you are going to request, of course, you are going to say that, hey, I want 5 GB or 1 GB for my pod. And also at the same time, you are going to say, hey, you know what? I might have multiple pods. I'm I might have some kind of access mode. Now, what are the kind of access mode that you can have? You can have read write once, okay? You can have read only many, read write many, or read write once pod. What is the difference between all of them? So, and I'm sure it will be here. This is what it means. And I think this is the most easiest explanation that I can give for these particular access modes. What is read write many? Read write many are the pods running on different nodes can access this persistent volume. Many here are many nodes. Please note this point. Don't get confused with read write many with read write many pods. No. Read write by the pods running on different nodes, many nodes. That's what it means. Read write once. All the pods running on the same node can access this persistent volume. But this persistent volume can't be accessed by pods running on different nodes. If so, how do we get to know that which node will that node be? So let's say that you created a particular deployment. This deployment has created 3 replicas, and all these 3 replicas are on the same node. Then there is no problem because you can define your mode as read write once, which your persistent volume will easily be able to serve. But if you have deployment and if you have 3 different nodes, so the first one will be able to read write it. The other 2 pods on different nodes will fail to access the persistent volume claim. They will not be able to access the persistent volume. Got it? Now, read only once. Read only once means the pods can access PV from one node in a read only mode only. Now you are getting, because it's not about pod, it's about nodes, because right, it is associated to persistent volume. Read only many. Pods can access PV from many nodes, but in a read only way. Read write once pod. Now this is a pod level access. If you want only one pod to access your persistent volume, okay, you can give this access mode to persistent volume claim and request it. And that's it. Only one pod will be able to read, write, or have access to that particular persistent volume. Now, these access modes must match between persistent volume and persistent volume claim when the binding is happening. If for some reason you have the disbalance of access modes, retention policy, I mean the claim policy, right? The claim that we have discussed, or the size. Let's suppose the persistent volume is of 1 GB, you are requesting 5, boom, nothing will work. You want your retention policy to be recycle, but the PV is created with delete. Of course, it's not going to work. Okay, reclaim, right? So this is the parameter. So when you create the persistent volume, you have to decide as an administrator, hey, you know what? I'm going to create some storage which will have the retention, some storage which I am going to delete, and some storage which I am going to recycle. You decide first when, as an administrator, you are creating. And then you are saying, hey, at the same time, the ones that I'm going to delete, I can allow it read write many, or maybe you have to give the claim for all the access modes, right? You might have to create all the access modes for delete, all the access modes for recycle, and all the access mode for retains to have all the necessary permutation and combinations that PVC could come up with. And now I really want you to take to one more theories section. So provisioning, there are two type of provisioning, static and then dynamic, right? So we are going to check the static one first, and then we will move on to the dynamic one. Binding, I have already explained you. The PV and PVC, they are bound. Okay. Now you can use some another parameters like claim reference for bidirectional binding. Otherwise, as I said, we have just PVC requesting for PV. All right. This claim reference is a parameter, which is little, tricky to use because you have to use claim reference in PVC and PV to, really match them one to one. Okay. All right. Type of persistent volumes. We discussed, right? Hostpath is one of the type of persistent volume. Then we have local storage devices that are mounted on the nodes. NFS is another type of persistent volume. EBS is okay. The following type of persistent volume are deprecated but are still available if you want to use them. These are one of them. Please install the corresponding CNI drivers to use these kind of persistent volumes. You have to install the CNI drivers. Okay. So that's what is explained in this particular section, that there are multiple type of volumes that are there in the market. Now, if you go a little bit of down, I will show you one more point. This, we have multiple plugins, we have multiple volumes, right? But not all of them have the access modes available. For example, the Azure file volume plugin or the type of volume does not allow read write once pod. They don't support the pod level isolation. They just support node level isolation. That's what it is trying to tell me in this particular graph. Okay, in this particular table. Let's move on. This is worker. So again, I will be using some kind of host path only. So I'm creating a directory called PV. Okay. And I will go back to my master node and I will be creating the persistent volume. Now, if you see kubectl get PV, PVC, store, I'll show you the storage class as well. No resource found. Okay. But try to do A means on all the namespaces, there is nothing. But if I show you kubectl API resources, and then I'm going to grab PVC storage class, and you will notice that PVC is a namespaced entity, PV is a cluster scoped entity, and the storage class is also a cluster scope entity, right? So now let's get started. I'm going to create the persistent volume pv.yaml, and this is my setup. Instead of data, I have already used data, so I'm going to use PV. And this is the persistent volume kind with the capacity of 1 GB, and the access mode which I have given is read write once. Okay. And the read write once means the pods running on the same node can access this PV, but PV cannot be accessed from the pods from different nodes. So since I have only one node, that's why I'm creating this kind of PV. All right. All right. So kubectl apply -f pv.yaml. Kubectl get PV. Now the claim policy is retain the PV. The storage class is manual. Manual means I'm giving the persistent volume manually instead of dynamic provisioning. I'm using the static provisioning. That's what I am trying to tell them. Is it available? Yes, it is available. What is the access mode? It is the PV is created with. It is created with the read write once. What is the capacity of this PV? And what is the name of this particular PV? Got it? Now, let's create the PVC. Now, this is my PVC. It is saying that again, the PVC, this is the kind, the name is PVC. The access mode, as I told you, is very important to match. Okay. And of course, the storage class is again manual with 1 GB, it is going to request. Now, let's see what happens. PVC.yaml. Now, if you notice that as soon as we created PVC, it actually got bound with PV. Because as soon as we created the persistent volume claim, it went to the PV and said, hey, it went to the cluster, in fact, asking for PV with read write only access. And he got it. And he bound that, he bound itself, and the PVC bound itself to this particular PV to serve the pod. Now, what we are going to do? The only objective is to create a deployment. Now let's get it created. And this is my deployment. So in this deployment, the replicas are good. We the volume mount. I am mounting it on HTML as always. This is the volume I'm using. And instead of using directly the host path, I'm using the persistent volume claim. And this is how you should use the persistent volume claim in your deployments or in your pods for that matter. You're going to give a claim name, which is the name of the PVC. What was the PVC name? My PVC. I'm going to kubectl apply -f deployment.yaml, kubectl get pods, and you will see it is getting created, running. Boom. Now let's go inside this kubectl exec-it bash, and I'll try the curl localhost. So you can see I'm getting an error. Why? Because as soon as the user share nginx HTML got mounted on mntpv, there is nothing that exists here, right? Eventually, what we are trying to do here, we are just trying to keep the persistent storage, persistent volume. So we have the PV here. Let's create our index.html file. This is my persistent volume, index.html. Now, if I try this time, it will work. This is my persistent volume. So that's how the volume on the worker node will ensure the availability of the persistency. Okay. Now, this was the example that I just wanted to give you because you have to understand the chain. But is this how you generally create the persistent volumes, persistent volume claims? The order remains the same. The only thing is that the provisioning got different, right? We don't create persistent volumes directly. Instead, we let the storage classes to create the persistent volume as soon as PVC requests the storage. Let's try that. Now, in order to try that, there are many things that will come into picture which you might not understand. Why? Because as a cluster, I have created one NFS server. I have to provision this. I have to, set up this NFS server, set up the NFS client, install the NFS provisioner within the cluster. These are the three things that we have never discussed. But I am going to do that in front of you so that you can follow this, in your own time. Okay. So what is the first thing? Set up the NFS server, set up the NFS client, ensure that the NFS provisioner is there. I'm going to do that with the help of Helm, NFS server. All right. Mm, let me connect first to Ubuntu, and I'm going to increase definitely the appearance. Let's make it 14. All right. Okay, so in order to install NFS server, this is one of the type of, right, persistent volume that we discussed just now, NFS. Okay. Now, apt get update, updating the packages. We have two packages to install, apt get install NFS common and NFS kernel server, because I am installing server. NFS server got and NFS client also got installed. Now I have to create a directory which will act as a external storage for my cluster. So I'm going to use it data NFS, and I'm going to change the ownership to nobody and no group. That's what the NFS uses. And then I'm going to change the mode to 2770/data/NFS. Okay, next thing is that you add, the storage information and the volume information in etc exports. All right, so I'll be running this command, and now I will start copy pasting so that I don't have to write it. Oh, some mistake. So this is the storage. Okay, this is the volume that we discussed. And now I'm going to make it available to my complete network. So what is my network? I'm going to go here, 172.13.18.66. And I think it is of /16 if I'm not mistaken. Yeah, it is of 172.31. So it's 172.31.0.0/16. And I will be putting everything inside my etc exports. All right, I will verify if the entries has been made. Yes, now they exist. All right, so once the NFS entries exist, I will just try to check it with the help of export fs command. Yes, so it is exporting this storage to the complete network. Now let me restart the NFS kernel server again, and let me enable it. Or let me check the status first. And I think enable was already done here. So enablement was done, I guess, yes. So I don't need to enable it again. Okay. And let me try the command which is called show mount -e and the name of my private IP. So this is my private IP. Let me try. Yes. So this storage is mounted via this particular IP to the complete network. That's what I have done so far. Now, what is the next step? Next step is to install the NFS client packages. Now, where do I want this storage to be available? To my complete cluster, right? So I will go to the worker, and in fact, I will do apt update, and I will run the client, so which is called apt install NFS common. Now, similarly, I will do it on the master node. I'll go on the master node, and then I will say apt update, and I'll be installing NFS common. Now, before I install the provisioner or do anything else, I really want to show you that kubectl get pods hyphen a. You see, I just have one application, the manual, pod that I created. Here, you will see the NFS provisioner pod running because that's what is going to pick up the PVCs and create the PV for us. It is going to be a compute, right? Secondly, currently, we don't have any storage class. And when we set up the NFS provisioner, we will see the storage class here. Now, all right. Now, in order to perform that, I am going to do it with the help of Helm. It's a package manager, okay, for Kubernetes. Next step. So since it is a package manager, I have to add the repository and install the Helm, install the NFS. So now I have to really work out on the Helm installation, NFS external provisioner chart. And in order to do that, I have to pick up the IP, show the IP here, and prepare the NFS command. So this is the command that will eventually be used. Helm install. I'm going to install, a component, a chart. We call it a chart from this particular repository and from this particular, it's also a kind of chart. I'm going to name it this way, but this is the remote chart name which we have used. If you don't understand, guys, please feel free, just leave it. It doesn't matter. But I'm trying to tell you here is that I'm using some kind of package manager to install these components. And when we'll understand Helm, the things will become more clear to you. The only thing you need to understand for now is I'm using some environment variables to set the NFS as per my environment. That's it. Okay, so it got deployed. All right. And now I just want to make sure that it is running fine. Yes, the provisioner is running. So once the provisioner is running, I'll be happily telling you that my storage class will be available. Now you see here, I defined the storage class with on delete reclaim policy as delete, right? I want to say that if somebody takes out the storage, just don't fill me, delete the PV as well. Okay. Now, my storage class is ready. What is the next step? Now I want to create directly the persistent volume claim and see if I can use use this storage class to create my PV. kubectl get PVC, kubectl get PV. These were the ones that were manually created. Now this is the storage class I have. I'm going to create another PVC, PVC dynamic.yml. And you see here how I am using the storage class name instead of manual. I'm putting the storage class name as the storage class which I have defined, NFS client. And you have to match it, of course. What is the PV which it will create automatically? It will create the PV of ReadWriteMany. Can this provisioner do that? Of course, I've already shown you the graph. Yes, it can. So NFS, ReadWriteOnce, it can do that. Now, how much storage I want? I really don't want to utilize 5 GB. I rather, satisfy myself with 1 GB. I'm going to create the persistent volume claim. Okay, let's see. kubectl apply -f pvc -d. Yeah. kubectl get pvc. Wow, what happened? I already see bound. Oh, sorry, this bound. And the PV name is little weird. So let's check kubectl get PV, the persistent volume, and you can see here, I have not created any PV got created as soon as I created the PVC. Who created it? Of course, the NFS client created it, bound it with the reclaim policy of delete as a read write once access. Now, can I use it in my deployment? Of course you can. Again, my strategy will remain the same. I'm not going to change my strategy for the deployments. So it's my dep dynamic.yaml, and I'm going to call it with the name, right? And I will be creating the volume with the persistent volume claim as NFS PVC. That's what I created here, NFS PVC, and I'll be mounting it at this location. I can use it wherever I want, but just for the sake of simplicity, I am using the same deployment because the focus is not on deployment for now. So, but you have to ensure that your deployment is finally getting created. So if it is running well, it simply means you have successfully mounted your volume. And if you want to be double sure, just check the description. kubectl describe pod and like that, and that's it. You will see the volumes here.
Thank you for watching this video. Now, all you need to do is click the link in the description below, or if you're just starting out, type k21academy.com/cka02 into your browser. Once you're on the page, enter your name, your email ID, and your phone number. Then click on register now. Now, here you will be redirected to a thank you page where you can easily add the session to your Google or Apple Calendar. This is your chance to gain valuable insights, so don't miss out. Click the link now and take your learning to the next level. See you in the session.